And we are live. So welcome everybody. I'm sorry we started a bit late. I hope everybody can hear us well. This is a webinar about DBT and duckdb. And last time we had our famous Thijs with us. This time we didn't, so apologies for that. But for the rest, it should be all the same. Everybody can hear me. If you can hear me, can you post something in the comments so we know somebody is listening? All right, awesome. I have the expert at hand with me again, Niels, but as last time I will do the introduction again. Hello, another Niels. Before we start with the content, I have a few questions for you just to see how much you're on board with DBT and duckdb already. Like every time something happens at data mine that we use a Mentimeter, so I'm going to do the same here. So if you go to menti.com and type in that code of scan the, it's not visible. No, it's black. Sorry, I think we have a black screen. Just a sec. Stop, I need to share again. Coming allow, poof. Right, yeah, now you should see my screen. So go to menti.com, type in the code 23544495. And then we have some questions for you guys. I'll wait a bit because I know this takes a while. In the meantime, we're getting, by the way, a lot of positive reactions on the previous duckdb thing we did. So apparently there's quite a lot of interest from you guys. So I hope you like this one as well. Okay, let's see if some people have entered the code already. We're going to start with the first question. So first of all, we want to know your experience with duckdb. Have you heard about it but not using it? Are you experimenting with it? Or are you already running it in production? If you just joined, you go to menti.com and use that code, right? 23544495. Okay. Most of you have heard about it but not using it yet. That's also, by the way, our experience last time. We thought like more people would use it already. But it seems like, it's still early days for real true adoption, right? There's a lot of hype and blogs, but true adoption is still like only 2 of you are running DBT in production, which I guess is fine, right? But it's good for us to know. The same question but then about SQL engine. So I'm curious, I guess most of you use SQL in day-to-day life, else you wouldn't be in this webinar. Which SQL engines do you use then for analytics? Do you use Spark SQL, duckdb, and you should be able to vote multiple here. Trino or Presto or Athena or whatever derivative. Snowflake, Redshift, Synapse, Postgres or other. I hope you can vote on multiples here, yeah. Okay, do Postgres. Okay. 3 other. Can you leave a comment like what is the other then? I'm curious. Snowflake. Did you see the comments coming in there, right? Or not?
I can see the comments, yes.
Yeah. All right, awesome.
The sound isn't very good.
The sound is not very good. Yeah, but that's tradition. And data minded, it's always bad sound. I'll check in a bit if I can do something about the setup. Okay, so it's very mixed. I think we can leave it at that.
Yeah.
And then, before I give the floor to Niels, and I'll try to figure out the sound again, what would you like to get out of the webinar? Is there something in particular that you're looking for? I'll wait a bit for answers to come in. You should have a background music. Okay, get to know DBT and its use cases, okay? What would be a good way to interface with big data and an object store? Okay. More use case in DBT with Snowflake. By the way, somebody taught me that DBT is not capitalized. I always capitalized it myself, and then somebody told me to not do that. All right. I'll already give the floor to Niels, so you can keep on posting some questions here. Alternatives to traditional DB engines. Then it's time to go to the actual presentation. Niels, I'll add your screen to the mix. Hope that works.
Yeah.
There we go. And the floor is literally yours.
All right. Thanks, Kris. Yeah. So before diving into what I did with benchmarks and comparing the different databases, just a quick recap. We did a webinar I think a couple of months ago on duckdb and. Before diving into that, let's look at why do we think DBT is a good fit? Well, what we see at a lot of our customers is that, well, data engineers, finding the right data engineer is difficult. So they typically have a lot more analysts or data analysts, people that know SQL very well, people that are proficient with the data, know it very well, more than that they have data engineers building their data pipeline. So the data engineering teams typically become a bottleneck. So in order to alleviate that, we see a lot of our customers looking into DBT because it would help make their data analysts more proficient, allow their data analysts to write these simple pipelines, and not all data pipelines you write are really complex, process high volume data. So if we would be able to leverage these data analysts more, that would be a win. And then why do we think DBT fits very well? Of course, because it's mainly SQL. It's SQL plus some templating. It's its purest form. Of course, there's a lot more to DBT, but in the purest form for me, it's SQL and some templating logic, nice lineage, documentation, tests, etc. But the fact that it's SQL makes it actually the differentiator from a lot of the other tools which you could use, Python, plain Python or pandas, etc. There you really need to do programming, and we see it's too big of a gap between for allowing data analysts to write data pipelines in Python versus if you would allow them to write their plain SQL code. It's a lot easier transition. Of course, there is always still a transition needed. It's not only SQL, it's DBT and the ecosystem around it. It adds some complexity, but we do believe that it's the right fit and it's well executed. So that's why we think DBT might help a lot of our customers, and that's why also these talks are mainly focused on DBT with then different SQL engines. And why do we need these SQL engines is because, of course, we need to run our SQL code somewhere. We could use the data warehouse, as we've seen. A lot of you use DBT probably with Snowflake or Redshift, and that's fine. That's very good for structured data, things you know well. But we don't want to push customers to push all their data to the data warehouse because it becomes typically quite expensive. So it would be very good if we could leverage a SQL engine that could just run on top of flat files.
Yeah, I also, maybe just to add to that, we also see a lot of clients, maybe you were about to say that, so sorry if you do, but very often, like, a warehouse is good at like reporting kind of use cases and analyst use cases, but you also want to do machine learning use cases, other use cases with your data. So we see a lot of our clients, the idea of your let's say your ground truth or whatever you want to call it, like the most of your data lands in a data lake or a lake house, whatever. So and then some of it can go to a warehouse, some of it can go to machine learning algorithms, some of it can be exported for an API, whatever. But it gives you a lot of flexibility to leave your data in object storage, right? So yeah, there also makes sense to not have data in the warehouse.
Yeah, that's completely right. And so for this use case, that's actually what this webinar is about. So we have the data in our data lake, but we want to use DBT to query it, to transform it, to basically make it useful for either later on be consumed through APIs or building a machine learning model. Of course, there are, again, multiple options to be used as a SQL engine. And in this webinar, I'm going to focus on Spark, Trino, and duckdb. And just as a high-level overview, we'll start with quick intros on all of them before diving into the benchmark. I'm not going to give you any exhaustive ideas on why Spark is important. For me, the main differentiator with Spark from any of the other technologies is it scales very well, and it can use commodity hardware in distributed fashion to process a lot of data. I like it a lot. I use it also quite often. It's open source, of course, which means that everybody can play around with it. It's also always a win for me. By the way, every technology I'm going to use today, I'm focusing on open source technologies because I think it's a plus to share those, because everybody can start playing with it. You're not limited to the people that pay for Snowflake, etc. So this webinar only talks about open source technologies, and those are the first ones I wanted to compare it with.
Although we already got reaction like, but how does it compare to Snowflake or to Fabric or to? But that's for later. You have some questions.
Yes, indeed. So that are the niceties. What is a drawback or a difficulty with Spark is, of course, it requires some infrastructure to be set up. It's not plug and play. You can't just, if you want to run at scale Spark on Kubernetes or on AKS, you have some infrastructure to manage, and depending on what type of company you are, this might be done by a platform team, or you might not have these people. So it can be a drawback depending on how it's used. A second thing, and I typically encounter at some of our customers at least, is that it might be difficult to master. Spark has a lot of configuration options. You can do a lot of complex things with it, but as the volumes increase, typically the troubles also increase, and you do need to learn how to use it, or what are the things not to do, how to use it best. And because it's a distributed technology, it's typically more complex than some of the other solutions out there.
Indeed.
Yeah. So that's Spark. So what did I do for this benchmark related to Spark? So I will use our own operator, which is conveyor operator, which runs creates Spark clusters on EKS, on our Kubernetes cluster. But you could do exactly the same setup with the Google Spark operator. It's a Helm chart. You can install it on your Kubernetes cluster, and you would get exactly the same results, or performance-wise at least. Just the usage is a bit different than what I will show you. So that's the high-level intro of Spark, and then you have Trino, which was previously called Presto, which is another and becomes very popular distributed SQL engine. They try to differentiate them a bit because they call themselves a federated query engine, which is a cool idea that you in one query could target different types of databases and aggregate the results. So you could connect to your Postgres on, I don't know, your Sybase database you have on-prem, and get results from those.
How we also use it at clients is just purely for ingestion. So we connect to all operational systems. We do a select star from those systems, land it in a lake, and then use the same query engine that we did for ingestion. We use it for processing also.
Yeah. It's also a distributed engine, so it scales very well. And then the downside, it's similar to what Spark is for me. It requires some effort to set up and learn the ins and outs, how to configure it correctly, how to get the best performance out of it.
There are managed versions of this, right? Of course.
Like anything, there is a managed version.
Yeah.
So, and then for me the second drawback is a bit from since we installed Trino again on our Kubernetes cluster, it feels a bit weird that it's a centralized installation. So it will be used by all queries we do, or every team will use that central engine, which might be a bottleneck, and you might have different performance if you have a lot of queries running against it, which is different than our setup in Spark, which basically creates the Spark cluster and the resources it needs for every job that we run, and it will just spin up new nodes as we need them. With Trino, you have a centralized system which will run all your queries. So it feels a bit, to me, it looks always a bit like that running on EKS feels a bit backwards to where you had more the on-prem setups, where you have the centralized processing engine where you run your jobs against.
Yeah.
So on EKS, it feels less useful, but that might be just for me.
Okay.
How did I install this? They have a Helm chart as well. I use this one. Nothing special. The main thing I needed to configure was the resources. So the different components of Trino, which is a master-slave architecture. So you have your coordinator node, which basically gets the query as input. It will then create the query plan, the different tasks for it, and it will send that information to the worker nodes that will actually do the processing, which is fairly similar to what Spark does with also the worker nodes
And so I guess you created well, ask it as a question, did you create a small Trino cluster then which is comparable to the single node duckdb install, or how did the hardware compare?
Yeah, so the idea of the benchmark is to make as fair as possible a cost comparison. So I use the same nodes and the same setup as I will use to run duckdb for Trino. Of course, you will always need two nodes for Trino, so there will be a coordinator node and a worker node, but the instances, they are the same size as I would do for my Spark jobs and as I used for my dbt and duckdb jobs.
And all the heavy lifting happens on that one worker node?
Yeah. Yes. All the processing happens at the worker node. So this is not too special. There are quite some resources you need to configure and tweak a bit, which is, well, in the beginning might be a bit difficult to see what is the difference between all of them. I think the Helm chart could be improved to basically infer a couple of these requirements, certainly the JVM settings, based on the resources you get, but that's just a starting point. All right, and then the last thing is duckdb. duckdb, very high level, quick intro. They use as a tagline, and I like it quite a lot, is that they call themselves a SQLite for analytics. If you know SQLite, that works very well. If you don't know SQLite, that helps not at all. It's an in-process database, so it runs along with your Python code, your Java code, and you don't need to set up any additional resources for the database itself. So it's a very simple system. It runs on a single node only, so it's limited in scale in that sense. You can vertically scale it, of course. You can create your node, you make it bigger, but you can't distribute duckdb across multiple nodes. So that's of course a limitation that you need to know. It has great integration with files on blob storage, which is why I think also it's a good fit and why I included it in this setup. So it's very good at reading data from a certain directory and putting that as the input for our transformations. It has experimental from the latest version, the 0.90, support for Azure built-in, for Azure blob storage built-in. I still need to test it out more in depth to see how that works in performance-wise. So for now, most of my testing is done. All of my testing is basically done on AWS with data on S3.
Okay.
So after this short introduction of the three technologies, this is what the benchmarking setup or the project that I created will look like. So I will use the TP-CDS benchmark, which is a very well-known standard for measuring the performance of different databases. For those of you who want to know, you can basically configure the size of your input data. And here I use 100 gigabytes as input data, so that means it will generate me data for I think there are 20 tables in total, with 3 or 4 being more fact tables and the other one being more contextual data. So there's a lot less in them. The fact tables, they grow typically quite big. But the total input data set is 100 gigabytes, and why I think it's important is I wanted to measure the performance of these different engines against what I call, or what we sometimes call, medium-sized data. What we see a lot of our customers, they don't process all the time terabytes of data, and I wanted to see whether there are better alternatives than Spark, for example, for these medium data sets.
And even the customers who do have terabytes of data, that's usually like 2 or 3 data sets, which are really huge, but like 90% of analytics in customers we see happens on data sets 100 gigabyte or below. And that's also why sometimes you read those TP-CDS benchmarks, like famously Snowflake versus Databricks, and they go to like, oh, I scanned like 5 petabyte of data and look, we're faster. Well, maybe, yes, but most of the use cases we see don't care about data at that size. Like most use cases we see are in this data set. And it's also important because if you do have like 1 or 2 really big data sets, you can really focus on optimizing that querying and fine-tuning it. Like for that special case, you can spend some time. But if you have 100 use cases that need 100 gigabyte of data processing, you cannot optimize all 100 of them, right? So you want some good baseline performance out of 100 gigabytes. So that's why I like the level you set there, 100 gigabytes. Makes a lot of sense.
Yeah, and then on the right, it's a bit the internals of how the different components that are launched for every query. You see duckdb runs together with my dbt code, so it's packaged in one image, so it runs as a single container or pod on Kubernetes. For Spark, we have the dbt logic that is executed, and it will be executed against the Spark cluster. In the example, a single node Spark cluster, which means that both the driver and the worker logic will run on that same pod. And then for Trino, you have the dbt logic that will be executed against the Trino cluster, which consists of a coordinator and a worker. And what's important here is that all the, let's say the dashed lines or the dashed components, they use the same size of the same node. And it's an M62X large, so it has a 32 gigabytes of RAM, 8 vCPUs, which is, let's say, a typical, a bit less than most laptops of data engineers, but so a commodity hardware, let's say. So nothing special there, and we want to see what's the performance of this commodity hardware against our data set. So I'll show a bit of the code next. All the information of the queries I did also to generate the data, you can also find on my GitHub page. The link is provided below. So let's quickly dive in a bit of the internal. So the project, this is basically what will be in the GitHub repo. There is some data on how to some information on how to generate the input data. Let's as an example. So this is an IDE that runs on AWS through our conveyor product, but that's not that important. So what I want to show is that, well, so I have some data on S3. I have a glue catalog that configures it. Just to give you an idea, with glue you get some information on what's the size of this input data. So this is one table, this is one of the fact tables, and you see the amount of records that it's 140 million, I think, give or take. But they're the rows itself are very small. It's I think the 3 columns, etc. And then next to that you have the dimension data. So this is just to give you an illustration of the input data and the size. I think it's quite representative for many use cases. All right. So how does the dbt code look like? So it's split it up for every of the SQL engine, because of course, well, while SQL is a standard, not all SQL is the same across these SQL engines. So there are quite some adaptations that need to be done across them. I'm just going to show you one model, just that you have an idea on what is the type of queries that are run. So this basically gives it queries all the sales that are done, and for a specific number of categories, it gives you the revenue for that different item, and also the ratio of what's the percentage that this item contributes compared to the full list of items that we sell. Let's say as a standard company that sells products. So these are the type of queries that the Deep CDS benchmark creates. There are, of course, well, there are hundreds. I'm not going to go over them. You can read them. They are quite representative of the different types of queries you would typically want to do on your data. As you see, changing the queries to be able to work with dbt is not super hard. The main thing you need to do is basically register the sources, and that's what I'm defining here. You basically say, well, okay, my input data is coming from S3, so it's an external source, and then for people who know dbt, you register your sources, and this is basically how I register the sources. It looks at my glue catalog and it says, well, okay, this table in this schema of glue, or if it in this schema of glue is where you need to look as an input data.
Do you know if duckdb lazily reads those? If you do select star from a tree, like, does it automatically read everything?
No.
It's lazy.
In a good way. Yes, in a good way. It pushes quite some things down that it tries to target only certain files that it really needs as well. So it's a bit like, well, the same as we do with Spark. It doesn't always query all the data. It distributes it and it filters down on the specific partitions that you need.
Okay.
So this is, in this case, it showed with Trino. The setup of the DBT itself is actually the same for every of the SQL engines. The only difference is the SQL code. Like I said, there are quite some differences. Certainly, Trino is more restrictive than Spark or duckdb in terms of its SQL dialect. There are quite some specifics where it basically doesn't want you to explicitly name specific columns. If you do an aggregation on top of some input data, you need to give it an alias, the column name, which is something that is inferred or implied by default in the other cases. That's one of the things, and also it doesn't do type coercion, for example, between SQL and dates. It doesn't try to convert that string to a date, which is done by for example, duckdb or Postgres as well. So those kind of issues are the most annoying ones that I encountered while creating the benchmarks of the different engines.
Okay.
So that's the DBT code. As mentioned.
Sorry, if there are any questions, leave them in the comments. Like, you can also ask questions in the Mentimeter if you want. We can also just put them in the comments and we can respond to it.
Yeah.
Sorry, go ahead.
No problem. So, as mentioned, so I package all DBT code in a Docker image, and it's run through Airflow. So I created basically a simple task for every query in Airflow and ran them sequentially. I don't want to measure the performance of simultaneous queries. I just want to run them sequentially. That gives also the fairest comparison, as I mentioned with Trino, where there is one instance which handles all the queries. If I would mix them, then the results might skewer. Might skewer the results between Trino versus the rest of it. And the Airflow code is very trivial. In this case, I use it's what we call a conveyor container operator, but it's very similar to what the Kubernetes pod operator would do in regular Airflow. Basically, what I say is I want to run DBT with a specific query. And the query is, in this case, the model. There are 100 queries, so there's just some stupid logic that filters the correct query. I didn't spend too much effort on optimizing this. I just wanted to run. And then, just as an illustration, so this is Airflow, which basically executes the different queries, where you can see the outputs. Whether they're successful. There are a couple of queries that didn't work, as you see here. I will explain a bit about that later. But most of them, you get the results, and in the output, DBT also puts the query time, or the timing it took, where I created a small script that scrapes it, and of multiple queries, I take the median of the result. So that brings me basically back to what are the results. So what is the performance? And I think what's the slide that you created? It's a chart that you created, Kris, and it gives quite an interesting view. As mentioned, there are 100 queries showing the results of the raw 100 queries. You can find it on GitHub. It's not that transparent or not that easy to show on a slide. So this is a small alteration on it. And what does it show? On the x-axis, it shows basically time buckets or time slices, and on the y-axis, it shows the number of queries that finished within that time slice.
So if we had like nicer tooling, this would have been 3 histograms. But because I did it in Excel, I'm blaming myself for like a software. But I hope you guys see the 3 histograms, right? Okay.
Yeah, so the idea is that it nicely shows that, for example, duckdb within, let's say, 15 seconds finishes more than half of the queries.
Yeah.
So you say 50, 54, 55, somewhere around that. So which means that a lot of the queries it's executing very fast. Also, Trino performs quite well there. Spark doesn't, of course. Spark only finishes its first query after 15 seconds, which is to be expected. Creating the Spark context typically takes a couple of seconds. It does quite some things on analyzing the query, what jobs need to be executed. So it's not the fastest for this amount of data.
This graph would look completely different if you did it on 100 terabytes versus 100 gigabytes,
yes,
right?
Of course.
So again, keep in mind this is 100 gigabytes of data, mid-sized data. And there you see, well, basically that indeed, like duckdb, because like it's tailored to that use case, is indeed faster for most of the queries, right?
Yeah. Yeah, and then you have the long tail, the thing I put in red there, where Trino and Spark on a couple of queries are very slow. It seems that DuckDB performs better there, but I do need to warn you, DuckDB also goes out of memory for 3 out of 100 queries, so those things are not taken into account in these metrics. So the last thing, I think all of the SQL engines have at the end a couple of queries where they have difficulties with, where probably some optimization or maybe some hints could be given to improve the performance and make them work well. The same is for DuckDB. Yeah.
There's a question coming in, like, are you able to do benchmarks with variable amounts of RAM? Curious to know how the RAM influences the performance of DuckDB. Any insight of this would be great.
Well, I could do
The answer is always yes.
Yes, it's possible to, of course, do the same benchmarking for different RAMs. At the moment, I didn't do it yet, so I don't know.
But I think it's worthwhile to correct me if I'm wrong, that we use less RAM than, like, we have a 100 gigabyte data set, and we have 32 gigabytes of RAM, right? So we like, it would be maybe useful to see, like, what if we have like double the amount of RAM as the data set volume, right? Because we should be able to do everything in memory. Now, what does DuckDB do? It spills to disk, or?
Yeah, so what DuckDB does for queries, if it reaches the limit of its available memory, it will try to flush quite some things to disk and try to make progress on the query. And try to make progress on the query. There is of course a limit, that's why some of the queries don't finish where there was no progress possible, but it's mainly to do, I think, to a specific join that it doesn't perform correctly. It's a join of two big fact tables where I think it does something wrong. I need to investigate that in more depth, or it might be that the latest version with the out of core hash joins might improve this performance. But as you mentioned, it's indeed either reducing the amount of RAM and seeing what the performance of DuckDB would, or increasing it would be interesting. And this is very very simple to do in my case, because it's one setting only I need to change.
I hear an update.
I can give you an update.
Even I can do it. It's that simple.
Yes. Oh yeah, it is very simple. All the setup has been done. It's just changing the node that it needs to run on, and that's it. Of course, well, I'm not the only benchmark, and you might think, well, you're doing a specific setup, your benchmark might not be as relevant. There's another one, the ClickHouse benchmark, which uses another data set, not a TPCDS. It claims to be more based on real-world use cases. Does some ad hoc analytics and also some real-time queries, and they also compare quite a lot of databases. So if it's a very interesting resource, if your database is in there, it might also be a good idea to check it out. I didn't know about it before. It was Tim that got me to it, and there you can also compare based on the different instance sizes. You can get the performance out of it. It also shows that DuckDB performs very well on that benchmark, given the size of the nodes.
But here the use case was not so much ad hoc analytics, but it was more just ETLing basically, like the DBT use case, just transform a whole bunch of data. Right?
This is just as an extra reference, might be useful. I'm not gonna dive in detail in this, but it's always a bit of a trade-off. Do I want to create my own benchmark or try to look at what else exists? I always find that the benchmarks are not exactly mimicking the use case I want to show or to test. And then that's why I created. I did it myself basically, and because I want to combine the querying of the S3 data, pulling it in, do the processing, and writing the results back to S3. While a lot of these benchmarks, also this one, they basically measure the performance to load the data and then to query the data, which when it's inside the database already. But it's a bit of a different use case, and it makes it also more difficult to compare it with Spark, because you need to segregate the loading from the individual querying, and you basically can't compare whether it can push down certain queries very efficiently, that it doesn't need to load everything. So that's why I created my own benchmark. I created it myself or recreated the benchmark.
Okay.
So, as I mentioned, yeah, the main difficulty is while SQL is a standard or the NT-SQL standard exists, every query engine has its own special cases, things they support, some small syntax changes or some difficulties, which means that even with DBT, where you could say I could create one DBT model and compile my SQL against all of the different databases, it doesn't actually work like that, because the DBT SQL code you want to write also already incorporates some database specific syntax. So you need to make some adaptations anyway, which is a bit of a was a bit of a bummer in this in creating this benchmark basically.
Okay.
So that's about all I wanted to show. Just to recap, so the use case we want to tailor is we have small or medium-sized data set, up to 100 gigabytes. That's why the input data set is chosen like that. We focus also on simple transformation, simple in the sense expressible in SQL, and not a fancy machine learning model I wanted to create. That's not the use case we're focusing on. So simple transformation that are easily written in SQL, and where DBT is a good fit. And then the result, of course, is that, well, DBT and duckdb, they perform the best on this data set, which basically comes down to, well, know what alternatives exist, don't pick the right technology for your use case, basically. And that's actually the goal I wanted to show here. Don't blindly take Spark because it's by default always used, because it might be inefficient for your use case.
Okay, cool.
That's
Thank you, Niels. In the meantime, I'm posting a few links. I hope that works. I think I copied pasted them together. So this is one link, and the other link. Sorry about that. Oof. So there's the. I can't copy paste.
you have to do GitHub, yeah.
Yeah. So sorry about that. But, so if you want to check out the blog that Niels written on this topic, you can go to Medium. And then there's also the GitHub that he mentioned is also referenced in the comments. In good tradition, we're going to go back to the Mentimeter because we still have a few questions for you and give you the opportunity to ask some questions as well. I'm going to share my screen again. Share screen. Yep. Here we go. Yeah. So as we mentioned in the beginning, we now tested Trino and Spark against duckdb, but I wonder if we would spend some more time on this, which other engines would you like to add to the benchmark? So if you're not there already, go to menti.com, fill in that code, and then here you have to rank them. Like number 1 is the one you would like to see the most, and number 7 is the least. So we know, we have limited time as well, we cannot test all of them. Curious to see which ones you care about the most. By the way, there's also a Q&A button here, so if you have questions, you can already pop them in the Q&A button. We'll wait a bit until we've ranked this. Okay. First answers coming in. Snowflake, Databricks, BigQuery. Not a lot of Azure love, AWS love yet. Nobody cares what AWS. Who runs data warehousing on AWS anyway?
Interesting to see.
We have Athena. Come on, go Athena. It should be similar performance. Well, similar. It should be relatively easy to do because it's also based on Presto, right? Or am I
yes, I think you're right. Relatively easy. Yes.
Yeah.
Should. But it might be more difficult to have a fair comparison because I don't know how to, well, you can't really specify the node size you don't know about it at all.
Same with BigQuery, and you just...
it's just...
What we also noticed, by the way, we had an internal presentation the other day on specifically on signups, and there was nothing to do with this, but then that person benchmarked signups, and there's a huge fluctuation in performance depending on, if you run it 10 times, you get 10 completely different results. I mean, you even did a Fourier transform to analyze it. There was some pattern in the delays. But anyway, just to say, it's especially those fully managed systems, it's very difficult to just run it 1 or 2 times and then draw conclusions because you might just be in a bad batch. Okay, but I think quite a lot of answers coming in like Databricks, Snowflake, BigQuery, those are the 3 winners.
Yeah.
Like Azure and AWS.
Bit less interesting.
Okay, good to see. Somebody voted for Fabric. Good for you. The next question is as well, like, well, we are learning a lot about duckdb ourselves. We like to share that learning. We like that. So we wonder how would you like to learn more about dbt and duckdb? Like, would you just like, thanks for the GitHub thing, I'm going to play around on my laptop? If at all, right? Maybe you don't want to learn more after you've seen this, but just want to learn on your laptop? Do you want to learn in an environment where everything is installed, so you can just get started without doing all the setup? Would you just like to see more blogs, videos, and webinars? Would you like to do a hackathon? And there, because we organized hackathons in the past, would you prefer in person or online? For me, but yeah, I'm not voting, but I'll share my opinion anyway. But I like the hackathon way a lot because you can listen a lot to webinars like this or read blogs, but then for me, I learn the most by actually doing it. And if you're in a hackathon mode, you're kind of forced to
Yes, yeah, that's true.
Yeah.
You're forced to engage.
Exactly. You cannot not do it. Okay. So, but I guess most people don't like the hackathon thing. I'm okay with that. Yeah, that's fine. All right, this is good feedback, so we know what to do next. Okay, then we go to Q&A. If there's questions in the comments, do you see the comments there? If there are questions, there are some questions here in Mentimeter. So other benchmarks that have tested duckdb versus Spark for data over 100 gigabytes. Is there a rule of thumb when Spark outperforms duckdb?
Well, it's not an easy to answer question. Well, let's start by if your data increases and the memory stays the same. So let's say you keep at 32 gigabytes of memory. There will be a point where duckdb's performance gradually goes down or might fail if it really can't make progress on certain queries. So Spark will outperform if I would use the same query and I would do it on let's say a terabyte of data. There will be a lot more queries where duckdb struggles and won't be performant. Where Spark will overall be a lot better because you can basically configure a couple of nodes that do the processing. It can parallelize a lot of things more. There is no single rule of thumb I have at the moment, but I do use the 100 gigabyte rule a bit as a differentiator. If you have really more than that, if you process a 500 gigabytes of data set, then Spark is would for me be my default choice. If you are below 100 gigabytes, then I would look at things like duckdb or any other alternative if you prefer more any other single node processing like a Polars or a Pandas if you prefer to write it in Python than in SQL.
By the way, I was just waiting, there's kids outside here, they're like super fascinated. I think they think we're famous YouTube stars. No, but I just want to add to that what you said. We see quite a few clients and they basically have a Databricks cluster or a big Snowflake instance for everything. And more often than not, it's like over-dimensioned hardware versus the use case you have, because that's more or less the default. But then if you have workloads that do need like a 10-node Spark cluster or something like that, or 2 extra large Snowflake instances and it still runs 2 hours, well, the likelihood of that being successful in duckdb is very low.
Very low, yes.
So for those use cases, definitely keep them in the cluster. I mean, it's super powerful to have distributed compute. Do it, but if you have things like sometimes I see like those big clusters and I think like this use case could run on my phone. And the moment I think something can run on my phone, it can definitely run in duckdb, right?
Yeah, and the nice thing is indeed that, well, the input and output is exactly the same, so you could easily swap for one use case your Spark job to duckdb without you needing to do any other migration, because the input will be again your data lake, your raw files on S3. The output will be your processed files on S3, which you can then later on use by Spark or anything else. So it's a very easy swap, and you can use case by use case decide when it makes sense and when it doesn't make sense. That's what I like a bit about the approach. It doesn't need it requires you to push all your data first to your data warehouse before you can do the simple processing. That's you can choose it as you go.
Exactly. I see there's two more questions. So, have you tested MotherDuck at all? Might be good to see some more content about that, showcasing some benchmarks and interesting features.
I had access to the beta before they were officially launched. I played around with it a bit, but I didn't do this kind of testing on it at all. I think it's.
But what is the set like? Is it like BigQuery? You just run a query and it result, or do you specify the kind of hardware it runs against?
No, they basically provision you the machines in the cloud where you can execute the query. It's basically like you would do a bit like what you would do if you would run it locally, your DBT, and if it would be attached to MotherDuck, they launch the instances and they manage all that for you.
Did you get to choose how big the instances are?
You get to choose how big the instances are. I'm not 100% sure, but I would guess so.
Yeah, because with BigQuery you can't.
You can't at all. Yeah, I'm not sure actually.
Okay, something to.
But I will.
to investigate.
It's a good question actually. I like I said, I didn't play with it a lot. Just some quick tutorials.
Okay. Next question: do you consider duckdb to be good for time series? Did you already consider it for specific time-based queries, such as by time scale? I don't think it has something particular for time series, right? It's just a fast analytics engine.
It's just a fast analytics engine. It's not particularly tailored towards time series. So would I use it instead of a timescale DB or a Prometheus? It depends quite heavily on which types of queries do you want to launch.
Yeah.
Are you primarily interested in during your time series in specific periods where you want to query, which basically come down to a couple of files or a couple of directories of days you want to query? Then it would be efficient. If it really you want to analyze trends over time, then I don't think it would be particularly a good choice or particularly performant.
And I guess, but correct me if I'm wrong, timescale DB has some specific syntax or concepts specifically for time series, right? That you don't have in a typical.
Yeah, I'm not
database.
that familiar with timescale DB, but I would, as I think of a time series database, they will have some concepts there that are more powerful or easily expressed. DuckDB, it's an analytics database, so you could call it a column-based store. So it won't be particularly performant there.
Okay. One final question here is can you talk a little bit more about how you could easily migrate from DuckDB to Spark? Would it just be a matter of reformatting DBD? Is there a specific, isn't there a SQL dialect difference between Spark and DuckDB? Well, I guess yes, there is a difference in dialect, right?
Yeah.
So 99% should work, but the 1%, you would have to.
So the DuckDB dialect or SQL dialect is largely based on Postgres dialect. So if you have something that works on Postgres, it will, 99% again, it will work on DuckDB. If you compare it if you go away from Spark, it of course depends on, first, are you running your SQL code already against Spark or not? If you do, I think the difference between Spark and DuckDB, if I compare, let's say, the queries I did in this benchmark, they were not a lot. Basically, the substring function is different, and then some small detail on how you name columns, how you alias columns with backticks versus normal, single quotes. Let's say so. The differences there are a lot less than with Trino I had, where there were quite some things I needed to change.
So it's not like completely blind. You say now poof.
No.
But 99% should work, right?
Yeah. I think the switch would be fairly doable. Yeah, it of course also depends on how you run Spark. For us, we run Spark on Kubernetes or Docker images. It's very simple to swap out the Spark with DuckDB because well you can package DuckDB in our Docker container. If you would run Spark on Databricks etc., then it would require you some work to well package it somewhere and then execute it on I don't know AWS Batch or also on the EKS cluster you already exist. So it a bit depends also on what the infrastructures you have to play with, whether it would be easy or not.
Right. With that, I'm going to remove myself from the stage if I can. I'm going to make myself bigger. We're here in the small corner. I wait, I do this. Here we are again. Okay, yeah, with that, I'd like to conclude. Social aspect. Yeah, Niels, that's why you would like a hackathon. I guess you have to talk to people. You can also do an online hackathon, Niels, but we won't approach you. You can stay in your couch. No, but anyway, we are planning on doing a hackathon regardless, even if most of you said like, oh, okay. We're going to do it regardless. For those who want more interactive learning, we'll try to keep on with the content as well, with the blogs, stuff like that. I hope a lot of you want to get started on your own. So there is a GitHub environment. If you want, there's the GitHub code base where you can just do a git clone and get started. If you don't have an environment set up for you, contact us because with Conveyor, it's very easy to get started, play with different technologies, deploy it, have an Airflow running next to it without managing PKS magic.
Yeah.
So you don't even have to do help install. Yeah, with that being said, I'd like to conclude. Niels, thanks again for this topic. It's a topic that creates a lot of discussion, so it seems like a lot of people are interested. Not everybody agrees with what's we say, I guess, but that's, that's
It doesn't have to be. The discussion is itself interesting.
All right, guys, have a good rest of the Monday and see you next time. Bye.
See you.